Hey guys, today we're going to talk about proportions. That word sounds very big and it sounds like it's going to be a very difficult thing to do, but a proportion is essentially just an equivalent ratio. But we're going to learn how to solve for equivalent ratios when the numbers might not be quite so nice or easy to work with. So I first want to start off by reviewing equivalent ratios. We talked about how ratios were very similar to fractions. So here's some examples. You've got 1 out of 2 pieces of pie, indicated right over here, number 1. That's going to be equivalent to 2 out of 4 pieces of that same pie, that same size, which is also equivalent to 4 out of 8 pieces of that same pie. And you can see that there in the picture. They can all be reduced to 1/2 or 1 out of 2 pieces of the pie. Here's another example of equivalent fractions or equivalent ratios. Anytime that we do have an equivalent fraction or ratio, we are increasing by multiplying or dividing. If I was going to go 12 to 3, I'd be dividing by 4. But you do the same factor for both numbers in your ratio. For the numerators and denominators, they need to either increase or decrease by that same factor. You're always either multiplying or dividing. So when we talk about proportions, the math behind proportions is in this image right here. If you had A compared to B, and the equivalent ratio would be C compared to D, if I was to write them in a fraction, then that would mean that A times D would be equal to B times C. If you don't believe me, let's try one. 1 to 2, our ratio 1 to 2, we're saying is equal to 4 pieces out of every 8 pieces. Is it true that 4 times 2 is equal to 8 times 1? It definitely is. So that proves that this proportional reasoning is in fact true. It's going to be true for any equivalent ratios or proportions. Now, sometimes they're not going to give us all 4 items needed for an equivalent ratio. So let's say I had my ratio 6 to 12. So maybe I bought 6 apples for $12. I want to know how many apples I bought for $33.60. Now, those numbers are not very kind. But here's our trick. Since we know that whatever we get when we cross multiply are going to be equal to each other, we can cross multiply the 2 values that we know. So those are those numbers that are circled in green. I know my 6 and I know my 33 6/10. X right here is called a variable. We know it represents a number. It's what we're going to be trying to find. We just don't know what it is. So let's say that I was going to start off by doing 33 6/10 times 6. When I do that math, I get 201, don't want to do that, 201 6/10. That's what you get when you multiply 33 6/10 times 6. Now, in order to solve for that variable, I'm going to take this other known value. My other known value means what other number do I know? So I know my 12. That's another part of the proportion or equivalent ratio that I know. I'm going to take what I got when I cross multiplied. I'm going to divide it by that last number. And when I do 201 6/10 and divide it by 12, I get 16 8/10. That would have been very difficult to find if we were just looking for, I don't know, what did I multiply 12 by to get to 33 6/10? That's going to be such a difficult factor to find. So this is a way around it. So anytime that you have a proportion where you're going to be solving for an unknown part of the proportion, we can cross multiply our 2 known values, and then we can divide by our 3rd known value. Okay? That's going to give you your other equivalent ratio piece or your other piece of your proportion. So 6 to 12 is an equivalent ratio or proportional to 16 8/10. 16 and 8 tenths to 33 and 6 tenths. We're going to do one that has a little bit easier math now, just so you can see that it really does work. So looking at this example here, I see my ratio as 2 to 7 is equal to x over 91. Well, I'm not sure 7 times what number equals 91. I'm not sure what factor I'm increasing by here. So instead of doing that method, I'm going to use my cross multiply and divide method. So I'm going to cross multiply 2 times 91, which equals 182. And I'm going to divide that by 7. 182 divided by 7 equals 26. Therefore, my answer for x equals 26. So I was able to find that equivalent ratio or that proportion by cross multiplying my two known values and then dividing by my other known. This is the exact same equivalent ratio proportion that we just saw in our last slide, but it's written a little bit differently. That's perfectly okay because in ratios, we know that the order that it's written in is very important. But as you can see, my 7 still lines up with my 91, my 2 still lines up with my x because those represent the same values. Maybe 7 and 91 are my wholes and 2 and x are my parts, whatever it may be. I can still solve this the same way. My two cross known values are 2 and 91. My third known value is 7. So I'm going to cross multiply my two known values that are across from each other or diagonal. Like I said, that equals 182. And then I still want to divide by my other known value to get 26. I get the exact same answer, x equals 26, because I set up a proportion. It's very important that in a proportion, your like terms are on the same side of the fraction bar. So for example, I'm going to assume that my 7 and 91 are both my wholes, and my 2 and my x are both my parts. If I was to write it as 7 over 2 equals x over 91, that would not work at all. Cross it off because my wholes are not on the same side of my fraction bar and my parts are not on the same side of my fraction bar. I know there was a lot of information and that proportions can be very tricky, so do not worry. If you need extra practice, make sure you comment on Google Classroom any questions or if you would like some extra help. We will work on this tomorrow in small group as well, but make sure that you took notes and that you're ready to complete your homework.